Okay, excellent. So today I wanted to shift these gear from plain Python to something which is much more practical, to numerical Python, which is called NumPy. So this is similar to many other modules, and I think we've used some modules before. In order to use it, you need to import it. So you're familiar with import, right? Import NumPy, right? And now you would be able to use different functions of NumPy. And if you type help on NumPy, you can see all the functions which it can offer. And while I'm not going to go in details through all of them, of course, but there are a bunch of different math, right? Floor, exponent, equal, cosine, and so on. So this module is tailored for you to use math, and in particular, the main thing it offers you to use the NumPy arrays. And when I talked before about the data types in Python, I said, well, Python doesn't have arrays, it has lists. So yes, it doesn't have arrays, but it has these NumPy arrays within the NumPy module. And well, typically it's sort of convention. When you import NumPy, you typically do import NumPy as NP, so that every time you use functions from it, you don't need to type NumPy, you just type these two letters NP. And the main thing in NumPy, as I said, is those NumPy arrays. So if in the past I could say, well, let me call it my list. All right, I had my list, which was 1, 2, 3, for example, right? So now I can introduce, in addition to lists, I can introduce arrays. So so this will be NumPy array, and here I can feed my list, right? So my list, and if I want to type it, so you see it treats it differently, right? In the input, it says array of 1, 2, 3. So it's a different type of object, although, well, technically it has the same data in it, but the operations you can do with this array are different, and they're defined within this NumPy module. Well, of course, I don't need to introduce a variable for my list every time I want to make an array, so I can make an array. Let me not call them so long. Let me just call it A. So an array of pi array. And if I want, I can just explicitly say here what I want to put into this array. So, and this is my array from 1 to 5. So in, well, mathematical sense, you could say, well, this is a vector, right? So it's a one-dimensional set of numbers. Well, in addition to vectors, of course, you can introduce metrics, right? So I can introduce an array, NumPy array, oops, let it be 1, 2, 3, 4, 5, and this is, oops, I need one more square bracket here, and then here 6, 7, 8, 9, 10. Did I forget? Yes, I forgot something. I forgot one square bracket. That's what's going on? Okay. Yeah, so now it worked well. So now B is a matrix of all these numbers, and you can, of course, you can introduce more dimensions if you'd like. The array could be, well, 1-dimensional, 2-dimensional, 3-dimensional, etc. So also, well, so far it treats it like integers. You can, when you introduce in a NumPy array, you can introduce the type right away. So I can make my array in a similar fashion. So NumPy array, and then say here 2, 3, 4, and specify the type here explicitly. So if I now call C, you see it shows them as floats. All right, we now know how to introduce arrays. The question is, what can we do with it? Of course, well, we can call numbers from it, right? If I say C0, it will give me the first number in my C array, or the 0th number, right? The 0th element. Or if we go to, let's say, B, and we can do 0, 0, it will give us, remember, B is more like a matrix. It's a two-dimensional array. So it will give us the element at the position 0, 0. Or we can do it B, but let us look at the B at the position of the, of the very last column, very last row, right? So this one, right? That will be indexed by -1, -1. Oh, just want to make it a little bit larger. Okay, so what else can we do? We can get the values in the column of the array or in the row of our array, which is quite useful when we're dealing with matrices of data. So if I go and say B, let's say 0, then column, right? It will give me this first row in my array, right? And if I say B column 0, it will give me the first column in this array, right? So this 1, 6. Well, we can get the numbers from there. We can overwrite the numbers, overwrite the elements in the array. So if I say B, let's say 0, 0 equals 100, well, now my B will remain the same, except for the element at the position 0, 0 will become 100. Then we can fill the entire array with something, with a function fill. I have to admit, I don't think I use it, but never. If we want to fill it, the entire array will be of -1s. And we can also, there are special cases when we want to fill arrays with something. So for example, if we want to create an array of ones, there is a function called numpy ones. And then here you give the shape of the array. Let's say it's a 2x2 matrix. So will be a matrix full of ones, size 2
I'm
by 2.
not sure I understand.
Oops. So what was that? That was
your share.
Okay, that was too bad. She doesn't understand me. All right. So with yeah, I have my window right on top of where it pops out, so I didn't even see it. Okay, so the other special case will be if we introduce numpy zeros. That's quite useful. You often want to create an array of zeros of a certain shape. When you need, well, then you would need to change some of the elements, keeping some of the elements as zeros. So this will give us an array of zeros, the same shape as this array of ones. And another actually quite useful tool would be if you already have an array, let's say this array with something, or let's say this array B, right, with a certain shape. You can create an array of zeros like the array B. That function will create an array of zeros, exactly the same shape like the initial array. And you can do ones like B, and again, it would be very similar. So I've been talking about the shapes of my NumPy array, and of course there is a function, there's a method shape, right? Or what would be, it would be property shape of an array, so which returns us a tuple, the two numbers for, well, in this case, which determines the shape of the array. So it has two rows and five columns in this case. And in fact, you can change the shape of the array. Oh, there is also, similar to lists, you can use the function length. And if you do length of B, it will give us give us the length of the first axis of the array. So in this case, this is 2. So with the shape, you can change the shape of the array. So for example, if you started from your B, which had shape 2 by 5, you can say, well, B1 would be B reshape. And you can reshape it into something which is, of course, somewhat consistent with the initial shape. You can change it into array 5 by 2. So look, oh, that's a bad example because I remember it's all -1s. Let me go back to the definition of my B, which was a little bit more useful. Okay, if you go up by whatever 20 lines or so, you'll get to your definition of B, and you can rerun these command again, and you get your B again equals to something more meaningful. And now it's going to be more fun to reshape it, right? B1 reshape, B reshape 5 by 2. And let me look at B1, and it's the same data, but shaped differently, right? So I'm changing the shape from 5 by 2, and if I now want to get the B1 dot shape, B1 dot shape, I would get 5 by 2 now. And it doesn't have to be, in fact, it doesn't have to be a two-dimensional array. You can use the two-dimensional array and reshape it into a single vector, right? You can do B reshape 1 by 10. And B2 is, as you see, well, it still shows as a two-dimensional array. If you want to make it one-dimensional, you can do just B reshape 10. Maybe like this. B3. Okay. Yep. Now it's a vector. Now it's a single-dimensional array. So with NumPy, you can play with your data pretty much whatever you want, whatever way you want, and reshape your arrays. There is another thing, actually. This is quite important when you think of matrices. And remind me, I'm always forgetting. You guys all took linear algebra or no? Okay. Did any of you take linear algebra? Oh, excellent.
Currently taking it.
All right. So for the others, are you guys familiar with matrices at all?
A little bit.
Okay. In the materials course, probably, or what, in physics, or where?
I learned it in differential equations.
Okay, interesting. No, that's I had an experience. I had one of graduate students with excellent graduate student, and with a chemical engineering background, and I found out he never took linear algebra. I was shocked because it's very hard without basic knowledge of linear algebra. It's very hard to do numerical things because everything is pretty much reduced to matrices. But anyway, we won't get in all those numerical details. My point was that in addition to reshaping, you can transpose your matrix, and if you have taken linear algebra, you would know what that means. It means, well, transposing. You don't need to do linear algebra to know what transpose means, because you can do it with any sort of table of data, right? You change your columns into rows, right? So if you had your before that's before. So let me show you what B is once again. So 1, 2, 3, 4, 5, 6, etc. And remember, we first reshaped it to this B1, right? So it's a different shape, but I want to emphasize this is different from transposing, and I can introduce B4 as NumPy transpose of B. And this thing, well, this array looks different, but this array is, in fact, we just took the rows here and we turned those rows into columns. So the first column is what used to be the first row here. All right, so many things you can do with them. So now let's get to a little bit more practical. So often you need why you need those arrays of data, because typically when you do some calculations, you're not doing your calculations for a single point, you're doing your calculations for a whole array of data, be those data experimental data, or be it something coming from a model or whatever. You're dealing with tables of data. Well, of course you can use Excel, of course you can use Google Sheets, but well, it's not always fun, especially when the amount of data and the number of operations on the data you have to do is getting, well, larger and larger. So often you need to start from some initial points, and you don't want to set them as, oh, let me start from 1, 2, 3, 4, etc. Right? You don't want to do that. So similar to for the list, if we wanted to define a list of numbers 1, 2, 3, 4, what would we do in just plain Python? So if I want to have a list equals 1, 2, 3, 4, 5, 6, what would I do? Remind me. No recollection. Sydney, you're muted. Oh, that's fine that you muted. That's on purpose. No, that's all right. Okay, guys. If are you all muted or what? So you use the range command. This is something which we discussed in one of the first classes, right? So if I do range 6, well, I won't get what I need. In fact, I will get, it doesn't show me. But what I need essentially is I need a range from 1 to 7. That's what will give me. And if I do for I in range, for I in B, print I, print I, you will get this list of 1, 2, 3, 4, 5, 6, right? So similar to that in plain Python, in NumPy, you use a command which is arrange. So if I want to introduce a list of numbers from 1 to 6, I would have NumPy arrange 7. And while that would make it from 0, of course, like everything in Python, if I wanted to start from 1, I probably would need to do NumPy arrange from 1 to 7. Yep, and now it will give me this array of data. That's not, obviously, that's, well, similar to the range command, you can do a different step. So for example, if I want to get from 1 to 35, right? And I don't want to get all of them, I want to get only the odd numbers, I would do the step 2, right? If I want to get only the numbers, well, with the step, let's say, I don't know, I can do it with a step 5 and so on. Right. This is quite convenient. However, I personally don't use it too frequently because when you do a range, it's actually what's inconvenient. Let's look at this initial thing. So if I do d equals numpy array at range 7. What's problematic here, if I want to count to 7, it doesn't count me to 7, it counts only to 6. So which is okay, but I prefer to use the alternative way, and that would be a linspace. So numpy linspace gives me a similar thing, a range of numbers. Oops, I did something wrong. I think I need to specify, in fact, for linspace, I think I need to specify the start, the stop, and the number of points. So that will give me the endpoints. That's why I would use it, but then it's from 1 to 7, and the number of points would be, oh, I don't think it's actually necessary. No, oh, that, no. Sorry, this is what I need, right? So the linspace give me the points in the range, but including the endpoints, unlike the arrange, which doesn't include the endpoint. It's also convenient. It's quite convenient to use in some cases to use the log space. So I can do the L equals numpy log space 1 2 7 7, and then it will give me a range of numbers where this corresponds to the 10 of the power of the number we need to specify. Well, sometimes when your data is going over several orders of magnitude, that's pretty useful. Okay, so now we know how to get data from NumPy array, how to change data in NumPy array, how to well, create some simple NumPy arrays. What else we need to do? We need to make some operations with them. We need to do some math on those arrays. So I'll remind you how it was for the list. So remember, if I had the list 1 2 3 and a list, let's say, for simplicity say this will be 4 4 4. So if I write a plus b, well, the result will be 1 2 3 4 4 4. So it concatenates the lists. It adds them as if they were strings, right? It adds the other one to the end of the first one. So if I do now by the way, you remember, right? So that capital A would be a different thing than a small a, right? So Python distinguishes between the small and capital letters and treats those variables in different. Okay, let me say A is NumPy array of A, and B is NumPy array of B. Guess what we're gonna get if we do A plus B? You can try it. You don't have to guess. Just try and see what you're gonna get. You'll get something totally different. You're not adding the two lists together. Because NumPy, unlike the plain Python, NumPy, well, treats these plus operation as a mathematical summation, right? You take one vector and you add another vector to it. You do it on, well, I don't know, saying, well, adding one vector to another is actually, it's not a correct representation. You're basically, you're adding those two arrays element wise. So each element is calculated from a sum of the two corresponding elements in the initial arrays A and B. So same with multiplication, same with division, same with you can do the modulus operation, right? So this is this is what when we divide with a remainder. So that's a big difference between the NumPy arrays and the lists. So essentially when we write Python functions and when we do calculations, right, you can do your calculation for an entire array of data, right, with just one line, with one operation. You don't need, basically, if you want to do an operation on a NumPy array, you don't need a loop. You don't need a loop to go through all its elements. Your functions will be applied to each element of this array if you call a function with this array as a variable. So if what else you can do with them?
Does raising to the power work the same?
I don't think so. Let's see. Yes, it does. So A power B. So that's yeah. I'm hoping. So what we had, it's 3 to power, yeah, to power 4. Yep, it works the same way. So some of the functions might give you trouble, but overall, no, overall, you're operating with them as if they were just numbers. Just each of them, you're forgetting that it's an entire array of things. It's just as if you have one number. And of course, the whole thing of NumPy is that you're able to use your math function. Remember, in the past, we were in order to use the math functions, we had to import math, right, and then do math dot sqrt of 16, right? Or math sqrt of, oh, actually, if I fit a list here, well, it can't do it on the list, right? It's because well, it doesn't know what to do with the list. So if you do, well, NumPy has all the same functions, right? You can do NumPy sqrt of 16, and it will give you a square root, right? So you don't need to use, I'm not saying you have to forget about the math module, but typically when you use NumPy, you don't really need math module. So NumPy already has everything there. But unlike this case, remember we had this array, this list A, and I wanted to take a square root from it. So if I wanted to do it, I would need to do for AI in A, so that I call every single element in my list A. I do print math sqrt ai. So that would do the thing. That would go element by element and take a square root from each of it. So the difference with NumPy, that in NumPy we can say NumPy sqrt, and then, well, remember that A capital was the same thing as my list A, except for it's a NumPy array, right? And well, I don't need a loop. My function square root applies to each element of the array automatically, and it spits out the square root, the element it spits out the array where each element is a square root of the initial array. So there are many other functions like that. So you know everything you can think about. It's logarithm, right? Or exponent, or absolute value. Well, that was easy. Or sinus, and so on and so forth. So now, in addition to plain Python, which was useful to begin with, you have a powerful tool when you can do your mathematical operations on a bunch of data by just calling a function of them. So some of the any questions at this point? So some of the useful things, which, well, as I say, many of the things you can do in Excel or now Google Sheets. In fact, I don't know, do you guys use Google Sheets, or do you use Excel when you need to do some calculations on some set of data? Just curious.
I think so.
Both.
Both? Yeah, because I started doing a lot of things in Google Sheets. It's just interesting how quickly things evolve. It's just so convenient. You have everything on cloud and you can share. Like I'm great. For example, this huge spreadsheet which I have for the class I teach, I share it with my TA, obviously. And I don't do any fancy statistics there. All I care is the average for each column, and I care about the sum for each row so that I know what everyone is getting. But nevertheless, it's just till recently I've been doing it in Excel. Now I do it in Google Sheets, and yeah, I don't do it in Python because there is nothing. Well, first of all, the array of data is not that large, and second, yeah, it's there's nothing too sophisticated to do with these data. So speaking of the data, you often need to do to do some simple operations on your data, and NumPy allows you to do it. Let's say, well, let me take some new array. Let me A, B, let it be C. So NumPy array, and let it be a one-dimensional array. So, but I just want it to be something a little bit better than 1, 2, 3. Okay, 1, 2, 4, minus 3, 7, 8.4, 1.2, and 3. Okay, let me. You don't have to use exactly the same numbers. Just make it a little bit more. Something a little bit better than just 1, 2, 3. Okay, so first of all, I can do a sum. Right? Oops. I did no. I think this is doesn't. Oh no, this. Oh, because I didn't call it A. I called it C. Yeah, so that would calculate the sum of the elements in the array. Or I can calculate the product, or, well, which I would say I use much more frequently, I can calculate the mean, and I can calculate the variance. And I think I can also do NumP there. I think that would be exactly the same. So you can call it as a property of the object itself, or you can say, well, it's a function on your NumPy array, and then feed your array as a variable to it. You can look at the minimum element. Oh boy, this is not. You can find the maximum element. You can find the index of the maximum element. So C arg max. Right, so it tells me where in my array this maximum element would be, and you can actually find you can do some things along the axis if your array is not one-dimensional. So let me reshape my array. So NumPy reshape C, and let me reshape it in the array 2x4. So now it's the same data, just in different shape. Now I can do some of the call some of those functions along the axis in the array. So C minimum. Oh, sorry, not C. D minimum along the axis 0. And okay, so it will along these 0 axis. It finds a minimum element in each, essentially in each of those columns, right? Or if I do it along the axis 1, it will find the minimum elements in each of those rows here. So I think the last thing for today is, sometimes you need to define your arrays explicitly. You just say, okay, this will be arranged from this to this, that would be arranged from that to that, and do calculations on them. But much more frequently, you have your data and you want to feed your data into the array. And this is one of the homework assignments you had. You were given a data file, and you were asked to read these data file into the some lists, right? And now we said, okay, we don't want to deal with lists anymore. We want to deal with NumPy arrays. And reading data from a file to a NumPy array is much more convenient. It's simple, it's straightforward, it's something, well, and it's fast also. So there is a, so you have these file, which let me actually, I think it would be more productive if when I need not to illustrate just one single command, but when I need to show you just a few lines of code, I think it will be more productive if I write a script for it. So first thing we would need to do in this script, of course, is to import NumPy as NP, right? We're importing NumPy. So in NumPy, there are several functions to load the data. The simplest one would be load txt, so which reads a txt file. Well, it doesn't have, by the way, in Python or in any other programming language, it doesn't matter what extension the file has. So it doesn't have to be txt or CSV. You can call it whatever you want. It could be file dot, I don't know, GOR if you wish. And what's important is the data which is there. And of course, while we're talking here not about binary data, but it's a text file by the type. So if I have my file, let me call it file name, right? Well, which was I think it was, data file txt, right? Data file txt. Make sure you have your data file txt. I think you had it for the homework assignment. Make sure you have it in the same directory, or otherwise you would need to specify the path to your file in order to read it. So then I say, well, data, well, this is just a variable name, right? I can call it my data equals, and then numpy load txt, and then here I feed the file name. And remember, there are two rows which are which we don't need to in our array of data, so we need to skip those. And there is an option in the load txt function of numpy is to skip rows, and the number of rows to skip is 2. So then, well, let's say all I want to do is just to print my data. Oh, I need to save the file, of course. So this is 04 load txt. Okay. Okay, so it did it. It's just one line, one command, which reads the file into a NumPy array. So, and then we print this NumPy array. And then we can read whatever data we want, and we can do whatever math we want with it. And you guys were asked to calculate the distances, right? So the distances between, assuming that these are the points, you had to calculate the distances between these points. So this is the length of the vectors, right? And NumPy, in fact, it has everything you need to do that. So you do just n equals NumPy lin algebra, right? And within the lin algebra module, it has the function norm, which returns you the norm of the vector, the length of your vector. And you feed your data there, and you can say along which axis you're doing it, and hopefully that's hopefully that's going to work. Yep, and it calculated, so it went through these vectors and calculated the length of each vector and printed that. And it does it. You don't look. We didn't need to write a single loop here, so it applies to all the data just by calling these function on the array of data. So, and for example, if I wanted to save this to the file, and again, this is typically when you do some sort of calculations, when you do it in Excel, you save it to the column to the right of your data, right, or somewhere. When you do it in Python, well, you have your script which runs and prints something. So while this is very useful at the moment, but if you want to revisit what you have done weeks after, right, you'd better have some record on that. So typically when you do some math on your data, you save it to another file, and it helps a lot so that you don't need to go and rerun your scripts when you need to revisit your data. So what I would do, and similar to the function load txt, NumPy has a function save txt. You can do NumPy save txt, and then you can call here, okay, let me call it out. Well, I don't need to introduce a new variable. I can just type here the file name. So output dot, and as I said, txt doesn't have to be txt, right? I can call it log, right? Output log, and I want to write my data in this file. And if I run it, hopefully it's going to work. And let me see if this file, this output log got created. Oh, it doesn't, Python doesn't want to open the output log file. All files. So it did it. it calculated the norms, the length of the vectors, and it saved it to the file. The only concern, which I know. Well, is there, when you look at these data, do you have any concerns? Is there something you like or dislike about it?
I don't like that it's in E form. I don't want it to say e to the 0 after ones that don't need it.
Yeah. For computer, it doesn't matter, right? But for us, if you want to look at these data, it's really inconvenient. And also, well, you know that, well, Sydney, you can confirm it to Jeff, who's currently taking my thermo, that in thermo 2, you would lose points for giving that many figures, because those figures, they don't mean anything, right? You need to round up to something reasonable, right? So Python, of course, gives you an opportunity to do that. So all you need to change is you need to write the format in which you save the data to your file. And well, in this case, since we're saving only one array and it's really one column, so it's very simple. So I'll do it in the format of float so that it's not exponential format, it's not scientific notation, and I will have so 10 digits total and four figures after the dot. So that should do a better job. So if I go now back to my output log, well, now I have these numbers in a much more pleasant format. Any questions?
I'm sorry, what was the 10 for? You wrote 10.4.
Okay, so this is so for when we have one column of data, it's probably doesn't matter that much. But this is the number of spots we have to write this number. So the total number of spots is for example, here we have 1, 2, 3, spaces, and then the number itself takes 1, 2, 3, 4, 5, 6, 7, 7 spots. So that's 10 characters to write this. So if we had two columns, that would basically determine the spacing between the columns for us. And if you make it too tight, then there will be problems with the numbers. Any other questions? Okay. So I think now we made a significant step forward towards using numerical Python, and now you will be able to work with arrays of data without writing loops for doing everything, and with you can read the data quickly. By the way, I didn't introduce the CSV module, but the CSV module, it has a very similar capability like this load txt. So yes, there you can write your CSV file with just one line, and we can start doing some calculations, which I will assign you as a homework. All right, let me stop the recording.